Okay, this is the start of video number 2. We're going to continue with the metric system. We're going to do area and volume. So let's start with area. So it's two-dimensional. Everything we've done previously was one-dimensional. So in 2 dimensions, let's say we want to change 1 decimeter cube or squared to centimeters squared. So it's two-dimensional. So if you could visualize it, it's an area. The length and the width are both 1 decimeter. When you square it, you get 1 decimeter squared. To change it to centimeters squared, we have to change each dimension from decimeters to centimeters. So if we just were looking for 1 decimeter to 1 centimeter, if you looked on your table, to go from D to C, you go down 1 space, 1 power of 10. So that's multiplied by 10. So this will be 10 centimeters. And likewise, this will be 10 centimeters. So when I multiply them together, I get 100 centimeters squared. Now, if I were to use the unit fraction idea, if you can't visualize this, then for unit fractions, you would say, and you would have to use 2 unit fractions, which equate 10 centimeters to 1 decimeter. So that's a unit fraction, and then you repeat it. So notice that the decimeters cancels twice with the decimeter squared in the numerator. You're left with 10 times 10, 100 centimeter times centimeter. That's how you get your answer, 100 centimeters squared. So let's suppose we want to go the other direction. We want to divide. So let's say we have 540,000 square meters. Or meters squared, and we want to change that to kilometers squared. Well, if I were going, remember now, meters is the unit. It's in the middle of your table. It's the unit. So if I go up to kilo, that's 3. But it's squared, so it's actually going to be 6. So starting here, I would move 6 decimal places to the left. So by that reckoning, the answer would be 0.54. So if I were to use the unit fraction idea, I would have 540,000. So 1,000 meters is 1 kilometer. 1,000 meters is 1 kilometer. Once again, the meters squared cancels in the numerator with the meters squared in the denominator, and so we're dividing this number by 1 million, which is 10 to the 6th. So it means move the decimal place 6 places to the left, which is what we did. Okay. Now suppose we change this idea from going from an area, a square area, to a volume, and we wanted to look at 1 centimeter cubed. How many millimeters cubed is that? Well, now I'm in 3 dimensions, so I could draw a box. The length is 1 centimeter. The width is 1 centimeter, and the height is 1 centimeter. All 3 dimensions are 1 centimeter, and when you multiply them, you get 1 centimeter cubed. So to change these to millimeters, on the scale, to go from C to M, you go down 1, so you multiply by 10. So this is 10 millimeters. So is this. and so is this. So you see that 10 times 10 times 10 would be 1,000 millimeters cubed. So in a linear sense, to go from millimeters or from centimeters to millimeters, you just multiply by 10. But when it's cubed, you multiply by 10 cubed. You got to use 3 powers of 10. Okay, let me erase this and we'll move on. There are some equivalences for volume and for volume of a rectangular solid and volume as a liquid. And that's on the part G on the second page of your formulas. Little box down here. Has equivalences of cubic units with liters. So let's say we were interested in changing 1,800 cubic millimeters into liters. So we need a unit fraction. So when you look at the table on part G, liters is actually in the middle, and it's decimeters cubed. And the closest I can get to liters is with decimeters cubed, as I said. So I can use centimeters cubed to milliliters or meters cubed to kiloliters. So I have a choice. So if I change this, it'd probably be a two-step process. So if I change this to centimeters cubed, we know that there's 10 millimeters per cubic centimeter, or per centimeter. But I want it cubed, so if I cube it, then this is essentially 1,000 millimeters cubed per cubic centimeter. So the millimeters cubed cancels, and I end up with, dividing by 1,000, I have 1.8 cubic centimeters. So now I can use the equivalence. The equivalence says that 1 centimeter cubed is equivalent to 1 milliliter. So I can create a unit fraction with this. They're not really equal. Well, they are, but it's more of an equivalence. So I multiply this by 1 milliliter per 1 centimeter cubed. The centimeters cancels, and so I have 1.8 milliliter. But the answer is in liters. So I've changed this to liters, and that unit fraction would be 1 liter is 1,000 milliliters. So the milliliters cancel, and now I'm dividing 1.8 by 1,000, so my final answer is move the decimal place 3 places to the left. So 0.0018 liter. So it's a two-step process. A lot of these are two-step. You have to go through a couple of equivalences. Okay? So let's see. Let's do a word problem that answers this or looks at this question with a larger dimensions. suppose we have a volume of water in a water bed. So that's a rectangular box. And it's 2 meters long, 1.5 meters wide, and 25 centimeters deep or high. So right away we notice that we got meters, meters, centimeters. This is 1.5. So we can't keep them on the same scale unless we change this. But remember now, centimeters, 1 centimeter or 100 centimeters is 1 meter. So to go from centimeters to meters, I would have to go up. That means I divide. So this is 0.25 meters. Right? So now I have all meters. So the volume, which is length times width times height, would be 2 meters times 1.5 meters. You know what? I think it's easier if we use fractions. Let's use fractions. So 1.5 is 3 halves, and 0.25 is 1/4. So the 2's cancel, and I get 3/4. So that's 3/4 meters cubed, or 0.75 meters cubed if you want to change it to a decimal. So the 3/4 I can write as 0.75. Okay? Now, the question is, how many liters is in the volume? Well, we have the volume as in terms of meters cubed. So when we go to our equivalence table, it says 1 meters cubed is 1 kiloliter. So 0.75 meters cubed, the unit fraction is 1 kiloliter is 1 meter cubed. That's the equivalence from the bottom row in number G. So the meters cancel, so I get 0.75 kiloliters. Which, if I want to change it to liters, I would just multiply by the 1,000, and so I get 750 liters. Essentially 3/4 of a kiloliter. If you multiply this by 1,000, you move the decimal place 3 places to the right. Okay, so let me erase this. So we're going to continue, and we're going to talk about conversions between the American system and the metric system. I'm pretty sure you recognize now that everything's pretty much based on unit fractions. And that's what the conversion table is on the back page. The conversion table between the American and the metric units. So, for example, what if we wanted to change 120 pounds to kilograms? So I would just start with what I'm given, and the unit fraction that I want relates pounds to kilograms. I set it up, and I put pounds in the denominator so they cancel. And if I look at the table, on the conversion table, under mass, I get 1 pound equals 0.454 kilograms. So the pounds dimension cancels, I'm left with kilograms. So all I got to do is this multiplication. And you can use a calculator for this, obviously. And then this multiplication comes out to 54.55 kilograms. My directions here say to the nearest 0.01 of the measurement as appropriate. So that's your 0.01, 2 decimal places. Okay, number 2. Suppose we want to change 48 inches to centimeters. So once again, I start with what I'm given, 48 inches, times, I'm going to put inches in the denominator and centimeters in the numerator, because that's what I want to end up with. So my unit fraction, according to the conversion table, would be 2.54 centimeters to 1 inch. The inch dimension cancels, and there's my another multiplication. And when I round out to 2 decimal places, I get 121.92. Okay? I got to remember to make these decimal places a little bigger. They show up better that way on the video. Okay, here's one with liquid. 42.6 liters is how many gallons? So we would start with the 42.6 liters, and my fraction is going to have liters in the denominator and gallons in the numerator. And if I look that one up, I get 1 gallon is 3.79 liters. The dimension of liters cancels. Now this one's going to be a division. So in the calculator I would use a division, and my answer to the nearest 0.01 unit would be 11.24 gallons. Okay, here's one we're going centimeters to inches. We'll go backwards. Number 2, we went from inches to centimeters. This one you should be able to see how it all fits together. 248 centimeters is how many inches? Well, I'm going to use the same unit fraction, only in reverse, upside down. I'm going to put 2.54 in the denominator and 1 inch in the numerator. So the centimeters cancels, the dimension of centimeters cancels, and I'm left with a division. 248 divided by 2.54, that rounds off to 97.64 inches. So you see the same unit fraction is useful. It just depends on what you're trying to cancel. Just make sure that the one you're trying to cancel goes in the opposite position. Usually start with the numerator, make sure the other one's in the denominator, whatever it is. Okay, one more word problem. So this one's a medical application. The dosage for adults is 1/2 milligram of a certain pharmaceutical drug for each kilogram of their weight. So the first sentence gives me the unit fraction. It's going to be 1/2 milligram is equivalent to 1 kilogram of weight. So this is the dose, and this is the weight of the patient or the customer. So I can use that either direction. All depends on how it sets up. So the next sentence says, if Paula weighs in at 138 pounds, what is her recommended dosage? Notice it's a 2-step process, because Here the weight is in kilograms, but Paula walks in and says she weighs 138 pounds. So first of all, I have to change this to kilograms. And if I remember correctly, that's 0.454 kilograms to 1 pound. That'll take care of the pounds. Now you can do these in the math in 2 steps, or I like to do them in 1 step. That way I round off at the end, and I don't have a round off there to deal with. So the next part of it says how many milligrams of the medication. So that's 0.5 milligrams per kilogram. So the kilograms cancel. So it's a multiplication. I multiply these 3 numbers together, and the nurse's assistant or the physician's assistant, the nurse, would get 31.36 milligrams as the dose, and they would round that off as appropriate, however they measure it out. 31.5, 31.25, whatever was closest to their measuring device. But this would be the recommended dosage for Paula, who weighed in at 138 pounds. I hope you get the feeling or the sense that all we do is find the right unit fraction, and everything works out. Swell. So that's video number 2. I'll look for you on video number 3, where we start our finances. We'll start with percents and interest, simple interest. We'll go from there. Dr. K, out.